So the question that we're faced with here today is from the Junior Cert Technical Graphics paper 2016, question 6 on the higher level paper. This has always been the ellipse and the parabola question. So as always, when you're given a new question and when you're doing one of these, what I would advise you to do, especially on the ellipse parabola question, always reading the information that they give to you at the very start before you even start to look at this kind of image in detail. So what it actually says is, the figure shows the design for a child's piggy bank. The curve ABCDE is an ellipse and point B is a point on the curve. Okay, so we've got the curve A, B, C, D and E, and they're saying point B is a point that is given to us on the curve. We have to determine the length of the major axis and draw the ellipse, and the curve KMN is a parabola with vertex at M. So KMN, it's a parabola and the vertex is at M. The lines PQ and RS are tangents to the ellipse from points P and R. So P is a point outside the curve of the ellipse, as we can see, and the line PQ is the tangent. R is the same tangent, but obviously just kind of flipped over to the other side, so the tangent RS. So there's a little bit of work in that one because that's coming tangent from a point that is P, which is outside the curve, so that's a little bit tricky there. And then it says, draw the given design showing clearly all constructions and points of contact. Okay, so when faced with this question, what you need to do is you need to work out obviously how you're going to come up with the solution to the problem. Okay, so what they've actually told us up here is a little bit of information. They've told us ABCDE is an ellipse with a point B that's on the curve. Okay, so I've got the ellipse, I have a point B that I can actually locate. So just working out straight away, they've told us to find the major axis, so we don't have the major axis starting off. Okay, we don't know the dimension from A to D. They haven't told us that anywhere on the sheet. If they haven't told us the major, I'll try and see if they told us the minor, and yes they have. So we can see the minor axis in this case is going vertically, which is always going to be when your ellipse, the short sides of your ellipse. Okay, these are the long ends, these are the short ends. So we do have the dimension from C to E because it tells us in here the minor circle has a radius of 55. Okay, so just writing that down, I do know I have the minor, and I'll just write in radius 55 there. Okay, so I know that, and I also have a point B on the curve. Okay, point B. Okay, so using those two bits of information, we're actually going to have to locate our major axis using that. They haven't given us the focal point, so that's what we're going to actually have to do to find it. Okay, so if we just look in here, we can kind of see the minor axis, we can see the minor axis is going vertically, so I'll actually just always write that in. I write in minor, and I know my minor is going vertically, up and down. And my major axis is obviously this guy, he's going here at the left, so I'll just write in major, MAJ, and he's going left to right. Okay, and I've got a point B on the curve. Okay, so I've actually explained how to do this construction in locating the major axis when given the minor and a point on the curve. In this case it's B, so I put a link to that video in the description for this video as well. Okay, but when doing that, what we have to do is, first of all, we note the direction of our minor axis, which we have learned is going vertically, and our major axis, which is going horizontally. So I'm trying to find the major. What that means is, from the point on the curve, I'm going to go parallel to the major axis. So if you imagine there, it's going to go parallel to the major axis, and where it cuts the minor axis, the minor auxiliary circle, which is right there. Okay, so I go from the point on the curve parallel to the major axis, and then through the center I will extend it out, okay, from there. And then from where B was a point on the curve, I'm going to do a line parallel to the minor, straight up, vertically. And the distance then, from there into my center, should be the radius of my major axis. So, now if I've done this accurate, depending on the sheet, yep, and as we can see there, it lines up with A. And it should line up with D at the opposite side. And we can see there, we've got the major axis. Okay, so starting off the question, that's actually where I would start on this guy here. Okay, so starting off, pick your center point. We're going to do a radius of 55 for the minor circle, and to locate B, it is up 40, and from the minor axis out 60. Okay, so starting off that there. So as you can see, I've already put in my minor axis with the center point here. So I know the direction of my major axis is going this direction. Okay, my minor axis was here. So if I've got my minor axis drawn in, my measurement's up to 55 here, radius, I will put in my minor circle. There's my minor circle. And as I said, B was up a height of 40 millimeters. It was up that height there roughly, somewhere along there, and out from the minor axis out a measurement of 60. So kind of pretty much bang on there. So straight away locate a couple of my points. I know the top and bottom of my minor axis are C and E respectively, and then I've got a point B here which is on the curve, so I'll put it inside here in this case, so I can see it's inside on the sheet. Okay, so following that method that I explained previously, this is our minor axis. It is going vertically, MIN for minor. Always put these in, just give me a little guide. I know my major is out here, so I'll just put in MAJ, which is going from left to right. Okay, and what I want to do is, if I'm trying to find the major, from the point I go parallel to the major from the point to cut the minor auxiliary circle. Where it cuts the minor auxiliary circle, I go back through the center, project it out, and to find the radius of the major axis from the point, go parallel to the minor, and right there we have located the radius of our major auxiliary circle. So now, having found that, I will put in my major auxiliary circle. There's my major auxiliary circle, and just zoom out there a little bit so you can see it a bit better. Okay, and we have a point on the curve, and now on my major auxiliary circle I've already located, I can locate A and D. So there's A right there, there's a point C and D, or C and E, sorry, and then D is out here. Okay, and I've already got B as well. So I found A, B, C, D, E. Now at this point it's very simple, concentric circles method to complete the portion of the ellipse. So I'm just going to speed up the video there now. So as we can see, I use the concentric circles method to complete my ellipse there. I didn't have it in just yet because I do know before I complete the rest of the question there's parts of the ellipse that are not all going to be heavy. So I'm just going to leave that till the very end when I'm tidying it up. Okay, but just where it cuts the minor circle, I go parallel to the major axis, and where it cuts the major circle, I go parallel to the minor axis to locate my various points around the ellipse. Okay, so we'll move on to the next part of the question now. Right, the next part of the question, I'm actually going to tackle this parabola down here, KMN. Okay, so when we're doing a parabola, what we're always going to do is we are going to create a rectangle, and we're going to use the rectangle method to complete it. Okay, so I'm going to create a rectangle around this parabola that has a length from K to N, which we already have, which is 54, and has a height from the base up here to M, which is actually our axis line, and M they told us was our vertex, which is V. So that's our axis line there. Okay, as we can see it, and the height of that is 20 plus 22, which is 42 altogether. So I need to create a box that's 54 long and 42 high. Okay, and that is actually in line with the center of my ellipse as well, which is where the minor axis was originally. Okay, so from there, from E I need to measure down 20 to get the line KN. Okay, and then obviously 54 divided into 2 is 27 either side. Okay, so from E down 20. Okay, so as you can see there, from E I need to project down about 20 millimeters, and what I'm actually going to do is project down 20 millimeters, do a line either side of it, and measure 27 either side to get 54. So 27 back, that will be K, and 54 over here, that will be N. So I can locate my points there as well. So there's K, and there's N. And at this point, I need to project up distance of 42, which we worked out, to get my rectangle. there's my rectangle, and up here I have also located M, which in this case is my vertex. And there's 3 points in my parabola starting off straight away. So starting off there, what we would always do is with a parabola we're going to divide up half of it. So I'm going to keep it on this portion here, so I'm going to do the portion that's K to M, and then I'll use axial symmetry to get the M to N portion. So what I'm going to do is I'm going to divide it up into about 3. Okay, so 27 actually, just realizing, 27 divides up into 3 quite evenly. 27 divided by 3 would be 9. So there's 9 plus 9 would be 18. So axis is going vertically, so at these points here they're going to go up vertically. There and there. And then 42 divided by 3, just thinking that actually goes in evenly as well. Yep, that goes in 14. So 14 and 28. So right there. Okay, so at this point here and this point here, I'm going to connect them up to my vertex, which in this case is M. Okay, and there now I have actually located points on my parabolic curve. Okay, now if you wanted a more accurate parabola, you could divide this line here up into maybe 4 or 5 parts, and the same with this line, 4 or 5 parts. So whatever you divide down here has to be the same on the opposite on this side up here. So if you did 4 here, you have to do 4 up here. I just did 3, just went into it nice and evenly. So what I can do now is I can sketch in my parabolic curve. So I'll just do that there quickly now. I'll speed up the video. Okay, that's half of the parabola done. Now what I'm going to do is to locate points here on the opposite side. Where I found this point here, I'm going to use axial symmetry to find it on the opposite side, and the exact same with this one here. Okay, if I wanted to find another one, I could take a point right there based on my sketch, just to prove it to you. So at that point there, it'll be the exact same distance to find the exact same point on the parabolic curve on the opposite side. So a bit of axial symmetry. Same with this one. And the final one here. Once again, speed up the video there. Okay, there we go. We've now found our parabola. So just looking in there, what we've actually done so far is we have completed the curve KMN, which is our parabolic curve. We've also got our ellipse. Okay, so we have quite a big chunk of it done here. And now what we're actually going to move on to, before we do these tidying up bits here, is we're going to get on to these guys here, which is our tangents. The tangent PQ, okay, and the tangent RS. Now the one I'm going to focus on at the start is the tangent, I'll do the tangent PQ, so I will. Okay, so what I first of all have to locate is the points P and R. So from D, it tells us, just locating out there, it doesn't tell us that distance, but from the middle it does tell us how far they are out. So from the middle it tells us they're out a distance of 110 there. Okay, so from the center of our ellipse they're out 110, and then they're up 20 and down 20 respectively. So I'm going to locate those points first. So from there it was out 110, and projecting up, line up and below, and just marking down and up 20 millimeters. So there's one and there's the other. And they are P and R. Okay, so what we have here is a parabola to our ellipse located from a point outside of the curve. Okay, we do not have Q, which is where it's going to be the point of contact where the parabola connects to it. Okay, so it's literally a line going like that. Alright, but we do have a P, which is a point outside the curve. Now anytime you're getting a parabola, what you have to first of all locate is your focal points. Okay, so when we get our focal points, which is going to be half the major axis by the minor, so take half the major axis, and I can go to the bottom of my minor or top, makes no difference. So when I locate those focal points, which are going to be called F1 and F2 respectively, what I do is from P I'm going to take the distance from P to F2 as a radius. Okay, that distance there, and I'm going to swing an arc. Okay, I'm going to swing that arc. Zoom out there a little bit. And then from F1, I'm going to take the distance of my major axis, which is that distance there, from A to D. And from F1, the other focal point, I'm going to swing another arc to cut that arc. And where those two arcs intersect, which would be here and here, at those 2 points, I'm actually going to join them to F1. But now, this one we actually don't need, okay? Because that's not going to give us my tangent point, okay, where the point of contact is. But if you look up here at this one, when I connect it back to F1, it should go through Q, okay? Close enough there. It obviously looks like that in the sheet, but depending on my accuracy and how it was done, okay, it'll come a little bit better on the drawing. But that is the method. So from P to F2, I swing an arc, okay, and then from F1, I take the radius of or an arc length of my major axis, swing an arc to cut it, and at this point here, connect it back to F1, and where it goes through there, that'll be my point of contact for my tangent, okay, and then we'll be able to connect P up to it, and the exact same to the opposite side, but we'll use a bit of axial symmetry. Okay, so I'll just do that there now. So zooming out there just a little bit, taking the distance. Oh, first of all, I have to find my focal points. So I take half the major axis. I'm going to this time just go up to C. Makes no difference. Go up to the top. There's F1. And there's going to be F2. Label them. Very important. F1, F2. Now, from P, which I have here, at P, make an arc length of radius P to F2. And as you saw on the sheet, I'm going to swing an arc. I'm going to keep it up this side because my tangent's going up here. And then I'm going to take the radius length or arc length of my major axis from A to D. And then from F1, an arc to cut that. And at that point there, where the arcs intersect one another, okay, what I'm going to do is I'm going to join that back to F1. And as you can see, it cut through my tangent right here. And where it cuts, it cuts through my ellipse right there. And where that cut through, I have now located the point of contact, which we know is Q. So at this point here, I can connect P to Q. Okay, and that is my tangent got. Okay, to find it at the opposite side, it will be the exact same thing, only in this case, rather than doing all that construction again, okay, I can just project Q down because the distance from here up to Q is going to be the same as here down to in this case, which is S. Okay, and there's my S, and once again I'll connect R up to that, and there we go. Okay, now at this point, just looking here, I have my ellipse got, I have my KMN curve got, and I have my tangents got. Now at this point here, it's actually just a little bit of tidying up, okay? So from B, I'll just zoom in there. From B up 14 to be able to get this little tail. So the radius of that little tail is radius 14. So from B, I'm just going to go up 14 and then just do a little semicircle. So just finding the center there, sorry about that. So just finding the center there of the ear, we can see from N projected up, and then from B projected across, where those two lines meet, that'll give us our center. Okay, and then it's literally a case of radius 24, so we'll swing an arc there, radius 24, and from this point here, which is on my minor auxiliary circle, I will connect that up to the center, that'll cut it off here, and from where E is, connected through the center and out the opposite side, and that'll give me my arc there, okay? And then to find the eyeball here, it's literally from that center point connected down to D, where that cuts through the minor auxiliary circle, give me the eyeball, okay? This bit here is just back 10 millimeters from the edge, okay, so that's quite easy. And then we've got these two kind of arcs down here, which are going to have a radius of 55 for the legs here. So from N, measure out 20, then another 55 to get the center point of that arc, just radius 55, and it's going to be the exact same thing at the opposite side. So I'll just speed up the video there now, and I'll do all the tidying up bits. Okay. Right folks, there you go, that is the question completed. It always says draw the given design showing clearly all construction and points of contact, so just make sure that you've located every letter. Okay, so A, B, C, D, E and the ellipse came in, and then the tangents P, Q and R, S and so forth. Okay, and that always your construction lines are clearly visible. They can be quite messy drawings, but obviously just going over the neat and tidy you are, nice sharp pencils, and then the final result, as you can see there when I speeded up the video, is this. I'll just zoom out there a little bit so you can see it. So just on finding the tail, went up 14, radius 14, from out here measured 20, then out 55, did an arc of 55 both sides. This bit came in here. You might think that little bit is wrong there, but if you look inside here, we can see it is clearly there. So do what's on the drawing. And then this guy up here, find the ear, was a little bit tricky. It was just a case of locating the center and then looking at your drawing, or looking at the sheet basically, to find all these lines here. Okay, so that's the question completed there. 2016 junior cert higher level question on the ellipse. Just realised actually at the very bottom I did leave out one little bit. So there was that little bit there. Sorry about that. Sometimes when you're doing these questions you forget it yourself. And that bit there is shaded in. You could do a little bit of shading if you wanted in the exam. But that is the 2016 higher level junior cert question.